Hello and welcome. There are times when the performance of the code is prime and you would prefer to implement the critical portion of the project in assembly language. I have dedicated this and next lesson on mixing the C and assembly code. In this lesson, we shall discuss about calling an assembly implemented function from C code and vice versa. To mix both the languages in an embedded project, it is important to know the register usage convention followed by the C compiler and how the parameter and return value are passed between the functions. Let's understand this closely. The register R0 is used as a temporary register by the compiler. If the register is used in assembly code, it must be saved on the stack before calling the C function. The register R1 is assumed to contain the value 0. If the register is used in the assembly code, the register must be cleared before calling the C function. The instruction CLR can be conveniently used to clear the register. The register Y, that is the pair R29 and R28, is used to hold the pointer to the stack frame. Generally, the registers from R15 through R0 are used with arithmetic instructions and R31 through R16 are used with load store instructions. Before calling the C function from the assembly code, save the registers being used on the stack using the instruction push. And when the C function returns, the register saved on the stack must be retrieved. Use the instruction pop for the purpose. The number of push and pop instruction must match, and the order in which registers are popped must be reversed to that of push operation. The compiler assigns the parameters passed to the register from left to right. The register set R25 through R8 is used to pass the parameters. The registers are always used in pair to pass the parameter. Though the data type character needs a byte, the compiler uses two registers to pass the parameter of type character. Two registers are used to pass the parameter of type integer, and four registers are used to pass the parameter of type long. If the number of parameters passed doesn't fit in the register R25 through R8, the stack is used to pass the parameters. Therefore, passing large number of parameters must be avoided, as setting up the stack with the parameters causes the performance hit. Let's understand how parameter and return value are passed with an example. The program implements a function test_2, which is called from the function test_main. Both the functions are implemented in C. The function test_2 accepts four parameters, two integers and two long integers. The listing on the right shows a portion of compiler generated assembly code of the function test_main where test_2 is called from. The registers R25 through R14 are used to pass the four parameters. The pair R25 R24 is used to pass the parameter a of type integer. R23 and R22 is used to pass the parameter b of type integer. Registers R21 through R18 are used to pass the parameter c of type long, and the register R17 through R14 are used to pass the parameter d of type long. Note the order of register allocation to the parameters. The leftmost parameter, that is a, is passed first in the register pair R25 and 24, then b, and so on and so forth. This is evident from the values assigned to the registers. The register used to pass the return value from a C function depends on the data type being returned. A data type of character is passed back using register R24, integer using R25 and R24, long using R27 through R24, and long which is a 64-bit value is passed back using register R25 through R18. The listing on the right shows a portion of the compiler-generated assembly code of the function test_2. The function test_2 returns a long type to the function test_main. The compiler uses the registers R27 through R24 to pass back the computed value. The same rules are followed when a C function is called from assembly code. The assembly code listed shows the example where the function defined in USART library is called. The code implements main function which initializes the USART and prints the alphabet in English language using sprintc function. The function init_USART is used to initialize the serial channel and accepts the baud rate defined as type long integer. The register R25 through R22 are used to pass the baud rate, and the function sprintc prints the character passed to it onto the serial console. Note, the register pair R25 and R24 is used to pass the character even though the character data type uses only 1 byte. Now, let's discuss the implementation of function in assembly language and see how it is called from the C code. A function implemented in assembly language is identified by its label. The function must be placed in .text section. Use the .section followed by .text to define the text section, and the function defined after the .section directive is placed in the text section. The function must be a global too. It is done by using the .global directive followed by the label name. Then the function body follows after the label. As shown, I have defined a function named divide_int. The function is defined to be a global using .global directive. If it is omitted, the function will not be accessible from the C code. The function receives two integer type parameters and a pointer to an integer. The parameters are passed in the register pairs R25 and R24, R23 and R22, and R21 and R20. The function returns the remainder of the division operation to the calling function. It is placed in the register pair R25 and R24 before the instruction return is called. Note that I have pushed and popped the status register in the function. It is a good practice to follow. The code shows the function call to the assembly function divide_int from the function main implemented in the C code. It is called as a usual C function with parameters. The compiler generates the code to copy the parameter value to the register as per the convention. However, the assembly function must place the return in appropriate registers before returning. In this case, the register pair R25 and R24 is used to return the value. Then, the C compiler generates the code to copy the return value in the variable reminder in the C code. This is how the function implemented in assembly language is called from the C code and vice versa. In the next lesson, we shall look into how to inline the assembly instruction in the C code text. I hope the lesson was interesting. Thank you and happy coding.